Graphing quadratic functions. So that is our topic for today. How to graph the quadratic functions. Okay, so we will relate the graph of this function f of x, which is equal to x squared plus 4x minus 2. We will relate the graph to the graph of y is equal to x squared. Okay, so first, we will graph the function f of x equal to x squared. So the vertex of this is at 0, 0. Okay, so the value of x, then this is your f of x. So your vertex is at 0, 0. 0 for x, then 0 for f of x. So you just plug in 0 to f of x. So f of 0 is equal to 0 squared, which is equal to 0. Or the vertex of any quadratic functions or equations of the form ex squared f of x, which is equal to ex squared, is always at 0, 0. Okay, so when x is equal to 1, you plug in 1 here to x, then f of 1 is equal to 1 squared, which is equal to 1. So right here 1. So if x is equal to 2, then you just plug in again 2 to x, then 2 squared is equal to 4. That's why when x is equal to 2, y is equal to 4, or f of x is equal to 4. Now, as you notice, if this is your vertex, then this refers to your axis of symmetry, EUS. Okay, and the axis of symmetry is simply the mirror image of the parabola. Now, the axis of symmetry, no need for you to solve for the other half of the values of f of x. You just reflect it to the axis of symmetry. Okay, so if this is equal to 1, then the value of y here is also equal to 1. Just reflect it along this axis of symmetry. So that means when x equal to negative 1, the value of f of x is equal to 1. Next is we reflect also the value of 4 to the other side. So this is also equal to 4 when x is equal to negative 2. So always remember these values because this is very useful when you are graphing other type of quadratic functions. Okay, so I will show you the technique or shortcut how to make a table of values when dealing with quadratic functions. Now, as you notice here, if you know the order difference in x and y, okay, from the vertex here, as you notice, from 0 to 1, so it increases by 1. Then next is increases by 3. So you will use this also to find the table of values of any type of quadratic functions. So plus 1, plus 3, what is next is also plus 5. So meaning, when x is equal to 3, then 4 plus 5 is equal to 9. So that's how important this 1, 3, 5 here. You are going to add always plus 1, plus 3, plus 5 when the value of A of your equation is equal to 1. So this is equal to 1. So when there is no coefficient before the x squared, that is the invisible one. The value of A is equal to 1. Okay, so next is, we will graph now that y is equal to x squared. So the table of values 0, 0, 1, 1, 2, 4, 3, 9. Okay, we will transfer here the values of x and y. Let's see x and then f of x. 1, 2, 3, vertex 1, 2, 3. So this is your vertex 0, 0. Plus 1, so therefore this is equal to 1 when x equal to 1. Plus 3, so 1 plus 3 is equal to 5. So that is when x is equal to 2. Plus 1 plus 3, next is plus 5. Okay. So plus 5, 1 plus 3 is equal to 4. So there is something wrong with this 5 here. So this is equal to 4. So when x is equal to 2. Next is plus 5. So therefore this is now equal to 9 when x is equal to 3. So these three values of x here, you just reflect it along this axis of symmetry. Axis of symmetry. So the reflection is, let's see, we will use another color for the reflection. Okay, so you reflect this 1 here, going here, so this is equal to 1. 4, this is also equal to 4. Then next is 9. So this is when x equal to negative 1, negative 2, then negative 3. Okay, so let's graph now the parabola of the equation y equal to x squared, or f of x is equal to x squared. So the vertex is at 0, 0. Next is 1, 1. So 1 going to the right, then 1 upward. Next is, no need for you to go back to the origin when you are graphing. Always use this point here. Okay, so go right by 1 unit, then go by 3. Go up by 3. Then next is, go to the right by 1 unit, then 5 units up. Okay, so that is now the half of your parabola. This is the vertex going to the first order pair, going to 2, 4, going to 3, 9. Now, since this is your axis of symmetry, EOS, axis of symmetry, that is your x is equal to 0. Okay, you just reflect this point along the axis of symmetry, 1 unit from the right. So therefore, 1 unit to the left from the axis of symmetry, that is the reflection of this point. Next is This is 2 points to the right, then draw its image 2 points also to the left. This point is 3 units from the axis of symmetry to the right. Draw also point 3 units from the axis of symmetry to the left. Okay, so connect now. This is now your parabola. Okay, so this equation represents your y is equal to x squared, or simply f of x is equal to x squared. Next is, how about the graph of f of x, which is equal to x squared plus 4x minus 2? So your focus here is to find the axis of symmetry, or simply the vertex. We know that the axis of symmetry is simply vertex is h and k. So the coordinate of your vertex is hk, where this one, the h is your axis of symmetry. Okay, so the formula for h is equal to negative b over 2a. That is now equal to negative of, your b is equal to positive 4. So therefore, negative of positive 4 all over 2 times the value of a, which is equal to 1. Okay, so simplifying, that is now equal to negative 2. Okay, so your value of k is equal to, k is equal to 4ac minus b squared over 4a. Okay, which is now equal to 4 times the value of a is equal to 1, c is equal to negative 2, then b is equal to 4. So 4 squared all over 4a. So 4 times 1. So that is equal to negative 8 minus 16. Negative 8 minus 16 all over 4. Which is now equal to negative 24 over 4, which is equal to negative 6. Okay, so therefore your vertex is at negative 2 and negative 2 and negative 6. So your vertex is at negative 2 and negative 6. Okay, so vertex is at negative 2, negative 6. So that is your, this is our x, and then your f of x. Negative 2, negative 6. 1, 2, 3, vertex, negative 2, and then negative 6. 1, 2, 3. Okay. So what we did before for y equal to x squared, we will do it here also. So we will just add 1 here. Plus 1, negative 6 plus 1 is equal to negative 5. When x is equal to negative 1. Next is plus 3, negative 5 plus 3, that is equal to negative 2 when x is equal to 0. So as you notice that the value of f of x when x equal to 0 is your y-intercept. As you notice, this is also equal to negative 2. So the y-intercept is at 0, negative 2. So when x is equal to 1, then you just simply add 5 here to get the value of your f of x. That is now equal to negative 2 plus 5 equal to 3. Okay, so this is our vertex, or negative 2 is our axis of symmetry. So therefore, you just simply reflect the value. Reflect the values from the right going to the left. So since this is negative 5, this is also negative 5. This is negative 2, so reflect that to the left. This value is also negative 2, then the other value is equal to 3. So from negative 2, this is negative 3. The value of x here is negative 4, then negative 5. So no need for you to plug in values of x to find the values of y. Okay, so let's do the graph of the function f of x, which is equal to x squared plus 4x minus 2. So the vertex is at negative 2, negative 6. 1, 2, 1, 2, 3, 4, 5, 6. Okay, count 1 to the right, then 1 unit upward. That is the plus 1. Count 1 to the right, 3 units upward. That is the plus 3. Count 1 to the right, 5 units upward. 1, 2, 3, 4, 5. Okay, so this is now the parabola. So half of the parabola next is just reflect along this axis of symmetry. So this is your axis of symmetry, EUS. So the reflection is 1 unit to the right, 1 unit to the left from the axis of symmetry. 2 units to the right, 2 units to the left from the axis of symmetry. This one is 3 units to the right, 3 units to the left. 1, 2, 3. So this is now the graph of the parabola y equal to x squared plus 4x minus 2, or f of x, which is equal to x squared plus 4x minus 2. Okay, so next is graphing quadratic function f of x, which is equal to x squared minus 6x plus 4. We will again relate the values of y equal to x squared. So this are the values of your y equal to x squared. 1, 2, 3. Vertex 1, 2, 3. So this is your vertex is at 0, 0. Again, plus 1, plus 3, plus 5. When x equal to 1, 2, 3. Negative 1, negative 2, negative 3. Reflect this 1 here to the left. Reflect the 4 to the left. then reflect the 9 to the left. So those are the values of your y equal to x squared. Now, we will find this equation, or we will just convert it into the vertex form instead of solving for the values of h and k. So f of x is equal to x squared minus 6x. This is plus 4. Now, what are you going to add to negative 6x, x squared minus 6x, to make it a perfect square trinomial? So, just simply get half of negative 6, which is equal to negative 3, then square. Negative 3 square is equal to 9. So, if you added 9, then you need to subtract 9. Because this is equivalent to the original equation. Once you added 9, you need to subtract 9. So this is now the equation, new equation in vertex form. So x minus 3 squared minus 5. So meaning the vertex is at 3 and negative 5. Okay, so since the value of a is equal to 1, then you will use the plus 1 plus 3 plus 5 to find the values of the function. Okay, so let's construct the table of values. X, f of x. 1, 2, 3, vertex, 3 and negative 5. 1, 2, 3. Okay, so again here plus 1. So plus 1, negative 5 plus 1, negative 4. Plus 3. Negative 4 plus 3 equal to negative 1. Plus 5. Negative 1 plus 5 is equal to 4. Okay, this one is when x is equal to 4, 5, and then 6. When x equal to 2, 1, and 0. Okay, so when x equal to 2, then that is just the reflection of negative 4. Okay, this is your axis of symmetry. So therefore, reflect negative 4. Reflect also negative 1. Then reflect 4 from the axis of symmetry. Then we are now ready to graph the quadratic function. Okay, so whether you are going to plug in f of 4, 5, 6 or 0, 1, 2, 3 to this function. Let's say we will plug in 5 or 6. F of 6 is equal to 6 minus 3 squared minus 5. That is now equal to 3 squared equal to 9 minus 5. So f of x, f of 6 is equal to 4. So this is correct. So we will now draw the graph. The vertex is at 3, negative 5. F of x, the equation in vertex form is f of x is equal to x minus 3 squared minus 5. x minus 3 squared minus 5. So your vertex is at 3 and negative 5. Okay, so no need for you to make a table of values. You can already graph the function if you already know the values of A and then the vertex. So what is important? You know the value of A and then the vertex. So our vertex here is at 3, negative 5. 1, 2, 3. 1, 2, 3, 4, 5. So this is the coordinate of the vertex. Again, count 1 unit to the right, 1 unit upward. That is the plus 1. 1 unit to the right, 3 units upward. That is the plus 3. 1 unit to the right, 5 units upward. 1, 2, 3, 4, 5. That is the plus 5. So this is now the graph of the parabola. Okay, and its image along the axis of symmetry. So what is the axis of symmetry? Axis of symmetry is simply equal to x equal to 3. Okay, so just reflect along the axis of symmetry each point of the graph. 1 to the right, 1 to the left from the axis of symmetry. 1, 2, so 1, 2. 1, 2, 3. 1, 2, 3. Okay, so just connect the points. So that is now the graph of your function in vertex form. F of x is equal to x minus 3 squared minus 5. Next is, okay, so this time is the value of A is equal to negative 1. So this one, instead of plus 1, plus 3, plus 5, you subtract 1. Subtract 3, subtract 5. Okay, so let's transform this into vertex form. You factor out negative 1. X squared plus 6x minus 7. Now, to make this a perfect square trinomial, we add 9. That is half of 6 equal to 3, then square equal to 9. So we added 9, but if you multiply that to the value of A, which is equal to negative 1, that is equal to negative 9. So meaning, we need to add 9. Because this one is positive 9 times negative 1 is equal to negative 9. So we added negative 9. So therefore, we need to add also positive 9 to balance the equation and to maintain the original equation. So f of x. So your vertex now, or vertex form of the equation is f of x is equal to negative 1 x plus 3 quantity squared plus 2. So what is the vertex now? So your vertex is at negative 3 and positive 2. Okay, negative 3 and positive 2. Okay, so we will form the table of values. F of x, so x, f of x. 1, 2, 3, vertex, 1, 2, 3. So what is the vertex? negative 3, positive 2. So, negative 3, positive 2. So, when x is equal to negative 4, that is equal to 2 instead of plus 1 minus 1. So, therefore, this is equal to 1. Negative 5. Instead of plus 3, subtract 3. 1 minus 3 is negative 2. Negative 6. Instead of plus 5, minus 5. So, negative 7. So, reflect now along the axis of symmetry. So, this is your axis of symmetry. Reflect 1 along the axis of symmetry, 1 here. Negative 2, negative 2. Then negative 7. When x is equal to negative 2, negative 1, then 0. As you notice here, this is equal to, again, negative 7. That is, when x equal to 0, the value of f of x is equal to the value of your c. The value of c. So we can now draw the graph of the function. So the vertex is at negative